Okay, so here's a question which says that the red dot that you are seeing on the screen starts to itself emit a sound of a frequency of 12 kilohertz. So that means this frequency, if it wasn't moving, would have been 12 kilohertz. Now it says that sound travels at a speed of 330 meters per second. Like I mentioned, that the speed travels at 330 meters per second, while the red dot moves towards the observer at a speed of 220, interestingly, kilometers per hour, not meters per second. Determine the observed sound frequency of the wave being emitted from the source. So what I will do is I'll write the equation down that f naught, the observed frequency, is equal to v upon v. I'll use minus because it's approaching the observer, vs into f of s. Now I know that f of s is 12 kilohertz. That's done. The numerator, we know that the speed is 330. Here we have 330 minus v of s, which is equal to f naught. Now I wrote v of s because I know that this particular speed is not 220, because 220 is kilometers an hour. So I need to do a little conversion here. So I know 220 to convert. I'll say 220 kilometers an hour is equal to 220 upon 3.6 meters per second. That's how we convert, which is equal to, if I use my calculator, I get 61.1, right, meters per second. So I can use that here. I get 330 upon 330 minus 61.1, and that's equal to the observed frequency, which obviously will be higher because it's approaching. So that's 14.7 kilohertz, because that was kilohertz, because you multiplied it by 12 kilohertz. So there you go. If the observer was standing in front of the vehicle and the vehicle is moving towards, you would get this higher frequency, not the 12 kilohertz that it was sent with, but an observed frequency would be a higher frequency, 14.7 kilohertz. Now it goes without saying that if you were a person inside this vehicle, what frequency would you hear if you were inside? That would obviously be 12 kilohertz. Because if you were inside, you would be hearing the same frequency, since you would be moving with the source and there would be no relative motion. If there's no relative motion, you hear the same source frequency. So if you were sitting inside, you would be moving with the source and you would be hearing 12 kilohertz. Okay, thanks.